Now we will be discussing what do we mean by tautological implications, or they are also called as logical consequences. See, whenever we have got a statement like this, if P then Q, this statement is called as an implication, it is called as a conditional, it is written as P implies Q. Now this is an implication, and depending upon the individual values of PQ, the implication may be either true or false. For example, if we take the four combinations of PQ, we have already seen this, but again we will revise it once. The result P implies Q may be either true or false. Whenever the antecedent is true and the consequent is false, whenever the left hand side is true but the right hand side is false, the result of the implication will be false. In all other cases, the result of implication will be true. Basic point is, an implication can be either true or false depending upon the individual values of, or depending upon the truth values of antecedents and consequents. However, there are certain implications which can never be false. There are certain implications which are always true, and the best example would be, and a powerful example would be this: P implies Q and Q implies R implies P implies R. Now you should try to understand one thing, that whatever I have written is basically an implication, it's a conditional statement, and this entire formula P implies Q and Q implies R, we will call it the left hand side, and this formula P implies R, we will call it sorry, a right hand side. And what I am saying, there are certain implications whose value can never be false. Their value will always be true. Let us consider, we will take three variables P, Q, R, then we will go for P implies Q, Q implies R, then we will go for P implies Q, P implies Q and Q implies R, and finally we will take this column P implies R, and the last column will be P implies Q and Q implies R. This entire thing implies P implies R. Now let us take the values for P, Q, R: false, true, false, true, false, true, false, true. Okay, for Q, false, false, true, true, false, false, true, true, and here false, 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 true, 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 true. Now first of all, P implies Q, we will populate this column. So it is the relationship between PQ. Now P true and Q false will be false. In all other cases it will be true. Okay. Similarly, Q implies R. Q is true, R is false will not be allowed. So we need to check it accordingly. True false and true false. Here this true false will be false. False false, false true will be true. Similarly, this true false will be false. All other cases will be true. Okay. And finally, we need to take ending of these two columns. P implies Q and Q implies R. So true and true will be true. True and true will again be true. True and false is false. True and true is true. False, true, false, false, true, false, true, false, false, true, true, true. Okay, so we are done with the column for left hand side, and after that we will draw the column for right hand side, which is P implies R. So let us see the columns for P and R. Now false, false, false implies false is true. False implies true will also be true. Then false implies false will again be true. True, okay, false implies true will again be true. True implies false, P implies R, true implies false will be false. True implies true will be true. Then true implies false, again it will be false. And finally, true implies true will be true. So what we have done, this is the left hand side of the implication and this is the right hand side of the implication. And finally, we will draw this column, which is left hand side implies right hand side. Now this is the left hand side and this is the right hand side. Let us see what happens. True implies true will be true. True implies true will again be true. Now false implies true will be true. True implies true, true. False implies false will be true. False implies true will be true. False implies false will be true. And true implies true will be true. Now you can observe that the final column of the implication, all values are true. And therefore what you can say, the implication P and P implies Q and Q implies R implies P implies R is always true. It cannot be false, and we know that a formula which is always true is called as a tautology. So whenever we have implications like this, the implications whose value is always true, the implications whose value cannot be false, the implications which are tautologies, then such implications are called as tautological implications. Again you can observe here what I have done. P implies Q, Q implies R, finally P implies Q and Q implies R. Now this is our left hand side, P implies R is the right hand side, and our final formula is left hand side implies right hand side, is value is always true. The implication is a tautology and such an implication will be called as a tautological implication. Now there are many meanings present here, hidden here. What is the first meaning? See, whenever the left hand side is true, okay, true, true, true and true. In 4 cases the left hand side is true. Now whenever the left hand side is true, the right hand side is also true, or whenever the antecedent is true, the consequent is also true. So you can observe true, 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 true. What we can say, whenever the left hand side is true, the right hand side is also true. And see, whenever the left hand side is false, for example here the left hand side is false, right hand side is true. Here left hand side is false and right hand side is also false. But we are not worried about what happens when the left hand side is false. What we are worried about, when the left hand side is true, the right hand side is also true. You can observe these cases. This is 1, 2, 3 and 4. I am again saying whenever the left hand side is true, the right hand side is also true. Or whenever the left hand side is true, right hand side cannot be false. Now such a case will be called as tautological implication. And in this case, the formula P implies R is called as a logical consequence of the formula P implies Q and Q implies R. So see, before going ahead, what I would like you to understand, we have written an implication. That implication consists of 3 other implications. P implies Q, Q implies R, P implies R. But the final implication is this one. Okay, wherein the entire left hand side implies the entire right hand side, and this implication is always true. This implication is sometimes true, sometimes false. This implication is sometimes true, sometimes false. This implication is sometimes true, sometimes false. The implication P implies Q is a contingency. The implication Q implies R is also a contingency. The implication P implies R is also a contingency. But the implication, the final implication, the implication P implies Q and Q implies R, imply P implies R is a tautology. So this is a contingency, this is a contingency, this is a contingency, but this implication is a tautology. And very simply, an implication which is a tautology will be called as a tautological implication. Not all implications are tautological, only some of the implications are tautological implications, and that is why it is not very difficult to see that whenever an implication is a tautology, you are going to say it's a tautological implication. It's an implication which is always true. It's an implication which can never become false. And now, after you are clear with this, we will see what do we mean by logical consequence. See, what I will do now, we will compare these two formulas. Okay, one formula F1 is P implies Q and P implies Q and Q implies R. And second formula is F2, it is P implies R. And we have drawn the truth table for these two formulas. Now here is one important observation. Whenever F1 is true, F2 cannot be false. Or where F1 is true, there is a guarantee that F2 will also be true, and therefore we say that F2 is a logical consequence of F1. And what it is called as F2 is a logical consequence of F1. Whenever F1 is true, F2 will also be true. Whenever F1 is true, F2 cannot be false. Whenever F1 is false, we are not worried about F2. So F1 is false, then F2 may be either true or false, that is completely okay. But whenever F1 is true, then F2 will always be true. Or what we can say, the truthiness of F1 guarantees the truthiness of F2. Or what we can say, that F1 is a stronger formula than F2 and F2 is a weaker formula than F1. Now why do we say F1 is a stronger formula than F2? We say because whenever F1 is true, F2 cannot be false. In that case, F1 is called as a stronger formula and F2 is called as a weaker formula, and this is called as a case of logical consequence. Now, F1 implies F2 is a tautology and F2 is a logical consequence of F1 are not two different sentences. They mean exactly the same thing. Now, I will write it down what I am trying to say. Whenever you have got two formulae, F1, F2, number 1, F2, okay, first we will see this. F1 implies F2 is a tautology. Number 2, F2 is a logical consequence of F1. Number 3, whenever F1 is true, F2 will also be true. Fourth, whenever F1 is true, F2 cannot be false. Number 5th, F1 is stronger than F2, and last one, number 6, F1 logically concludes F2. See, this is the symbol for logical consequence. You can read it as F1 concludes F2, or you can say F2 is a logical consequence of F1. So basically, tautological implications are nothing but implications which are always true. Implications which can never be false are called as tautological implications. Whenever you have got a tautological implication, you have got something of the format F1 implies F2 and F1 implies F2 is a tautology, then F1 implies F2 will be called as a tautological implication. Here F1 will be a stronger formula as compared to F2. Whenever F1 is true, then F2 will also be true. F1 is true and F2 is false will never occur, or when what we can say, whenever F1 is true, F2 cannot be false. So such formulae will be called as tautological implications, and there are two more things that can be said. Number 1, F2 is a logical consequence of F1, and another thing that can be said is F1 logically concludes F2. Whenever F1 is true, F2 cannot be false. Such formulae are called as tautological implications. And what I said, not all implications are tautological implications. For example, let us see. Let us consider an implication which is not a tautological implication. For example, saying P tautologically implies Q is wrong. Because if I say P tautologically implies Q, I am to say P implies Q is a tautology, which means negation of P or Q is a tautology, and all these statements are wrong. P does not tautologically imply Q. P implies Q is not a tautological implication. P implies Q is not a tautology. Negation of P or Q is not a tautology. And the reason is very same. You put P equal to true and Q equal to false. This will become false, or false will become false. This formula can be made false, and therefore we cannot say that P implies Q is a tautology. And when we know that P implies Q is a tautology, what we can say, whatever I have written here, that P tautologically implies Q is incorrect, is a wrong statement that I am making. It is not correct. You may write down anything. You may write down P tautologically implies Q, but your statement, whatever you are telling me, see here what you are telling me, that P implies Q is a tautology, which is again incorrect. Okay, so certain implications you cannot say are tautological implications, whereas certain implications are always true and they will be called as tautological implications. So see, there is really nothing very different, significantly different about tautological implication. It is only one way of saying that an implication is a tautology. See, before concluding, I will do just one thing. And what is that? whenever we want to say F1 implies F2 is a tautology, what you are going to say that F1 tautologically implies F2, or what you can say that F1 concludes F2, or what you can say that F2 is a logical consequence of F1. So this is all about tautological implications or logical consequences. Thank you.